In this video, we are going to look at subtraction, and we're going to use our cubes, rods, and flats to help understand how subtraction works. This is one of the most difficult things in my experience that students have to do. There's just something about subtraction that can be really problematic for some people. Some people take to it like ducks to water. I was not one of those people until I understood what I'm about to show you. So in your reference notebook, the last page we did was using models and equations, where we looked at some of those bar models to understand our word problems. So on the next blank page in the math section, I'm going to call this one, let's just use the same title. Oops, didn't mean to do that. Not sure what happened there. Let's just use the same title in the textbook, and it's using models to subtract. So for this page, I'm going to give it a title. Always put your main idea up here. Use models to subtract. And instead of trying to copy and paste and do all of that good stuff, I'm just going to use some drawings to represent my different models. I'm going to let a dot represent one of the cubes, one of the ones. A rod, I'll just make a straight line. And then a flat, I will use a square. So a cube represents 1, a rod represents 10, and a flat, of course, represents 100. So let's get an example problem to work with. This is page 26 in the textbook. Use drawings as models. You can model subtraction with simple drawings. Use the following simplified drawings to model the values shown below. A dot to model ones, a line to model tens, and a square to model hundreds. And here's the example. The running club wants to sell 450 t-shirts. It has sold 125 t-shirts. How many t-shirts are left? And just so that I can copy this into my notes, I'm going to take a screenshot. And it says, sure you are. Let's try this. Just want to take a picture of that because I cannot remember it to bring it to my notes. And you can just copy it as I write it. This will help us both. So I'm just going to put it right here for the moment, and let's write this question into our notes. Can't write in the textbook, so let's bring it where we can work with it. And you can pause the video. Remember, you can also speed up the video. If I'm moving too slowly for you, you can set your playback to double speed. Okay, the running club wants to sell 450 t-shirts. I'm just going to say shirts. It has sold 450. So you could use a bar model here if you wanted to. But there is a reason they want us to use the cubes, rods, and flats. So I'll do what they want me to do. How many shirts are left? And since this is a word problem, let's use that word problem strategy that I've shown you before. It will work with any type of word problem. Even when you get into algebra and those really long word problems, it will still work. So the first thing I want you to get in the habit of doing is looking for that question. And here is the question. How many shirts are left? And the key word here is left. That means subtract. If I see that word in a question, I know that I'm going to have to subtract to solve my problem. And then you also want to mark your numbers. You can circle them, whatever makes sense to you. We have 450 shirts and 125 shirts. So these are the key elements of this problem. So to solve the problem, I would be doing 450 minus 125. Now, if you know how to borrow, you don't have to watch this part of the video. I would encourage you to, because you need to know why you're borrowing. That will help you do algebra later on. It will help you do lots of things. So you always need to know why you're doing something. So here's how they want us to do this problem. They want us to model it using those symbols. So I'm going to draw 4 of these, and rather than, well, I'll just draw them. That's probably faster than 2. They don't have to be perfect. So you go ahead and do it with me so that you have 4 of the hundreds. Then we have 5 of the tens. And we have 0 of the cubes. And then for the bottom part, I'm going to say there's a 1 in the hundreds place, 2 in the tens place, and 5 in the cubes place. So on top, right here, I have 4 hundreds, 5 tens, and no ones. Here I have 100, 2 tens, and 5 ones. 125. So the problem is right here. I can't just bring down those dots. I need to subtract them from something. And so here's what we're going to do. Let me zoom in right here, just so you're focusing with me right here. I'm going to take this rod and write it as 10 ones. 2, 3, 4, 5, 6, 7, 8, 9, 10. So I took that one rod and I wrote it in its unit form. I made it into those 10 dots. So it is no longer here. We are now looking at it as its deconstructed part. So we have 10 of those. And now I'm able to subtract here. Okay, so let's do that carefully. We're going to do it by saying 10 of those green dots minus 5 of the black dots. So essentially what I'm doing, I'm matching these up. So I am left with 5 of those green dots. And then over here, I have 4 rods. Take away 2 rods or cancel out 2 rods. So I'm going to be canceling these 2 and these 2. So I am left with, and remember we renamed this one. Sorry, let me get all of those out. I hope I'm not confusing you here. We're going to do more than one of these. So let me go back and redo that. And I'll quit talking about stuff that doesn't matter. Okay, so what I'm going to do, we have already rewritten this one. So let's take it out. And then I'm going to take out one on top and one here. I'm taking away. Take away this pair. And here I'm left with 2. There's nothing down here to cancel. So I just bring down those 2. Okay. Now here we have 4 on top, 1 on the bottom. So we're going to cancel a top and a bottom. You have to take one of each. And that is going to leave me with how many of those flats still to count? 3 of them. So I'll bring down 1, 2, 3 of the flats. And so my answer will be 325. And if you do that using the algorithm, which is the old-fashioned way, you will see, let me do it right here. I'm going to borrow one of the 10s and make it a 4. This will become a 10. And look at that. That's exactly what we did over here. We borrowed 1 and we wrote it as a 10. 10 minus 5 is 5. 4 minus 2 is 2. And 4 minus 1 is 3. So the answer is 325 shirts left to sell. Now you might be thinking, I know how to do this. So why do I need to know how to do this? I will tell you, if you can do this every time and get it right, don't worry about this for now. Just do the algorithm and you'll be fine. If you struggle with this part, seeing it this way may help you tremendously, especially once you get the hang of it. So we're going to do more examples here. Let me go ahead and mark off a space. I don't want it to all run together, so let's go ahead and draw a line there and make room for our next example. So when I go back to the textbook, we see that their answer indeed matches ours. There are 325 t-shirts left. You can also use an open number line to model subtraction. Fran needs 750 points to get a free sandwich. She has 475 points. How many more points does she need? So again, let me just take a picture of this and we'll bring it over to our worksheet to work on it right here. But let's write it into our notes because we can't write in the textbook. Unless your teacher has told you that you can write in the textbook, but I'm guessing probably not. All right, so Fran needs 750 points to get a free sandwich. End of sentence. She has 475 points. End of sentence. Here comes the question. How many more points does she need? Question mark. So in your notes, if you have a highlighter, I want you to highlight the question. That is a very good habit to get into. If you're doing, you can't do it on a test, but as you're learning, it will help you if you will highlight your question. Trust me, just go ahead and highlight the question. And then I want you to put a box around this phrase. How many more? When you see that phrase in a question, you need to subtract. So if you're taking the high set or the GED and you're looking at your question, you need to subtract. What do you need to subtract? You need to subtract points. So when I look back here in my sentences, I see 750 points and I see 475 points, And I know that it's points I need to find. So it's pointing me to what I need to do. So we have 750 minus 475. Now, if you know the algorithm, you can go ahead and do it right there. I am going to do the number line like they want me to do. So let me look back just to see how they're doing it. Okay, I see. This is a good way to do it. So let's draw a number line. In fact, I might like this better than the first way, but you get to choose what you like. So on the number line, we're going to put 2 dots to represent our 2 numbers. So there's a dot and there's a dot. And this is the larger number, so it's 750. And this is the smaller number, 475. And we are looking for the distance between those. How many points are between those 2 dots? So they have taught us to go to the nearest benchmark. So I know that 500, I have hiccups, I think. There's the nearest benchmark. And then we would have 600, then 700. And so let's look at this number line a piece at a time. From 475 to 500 is 25 points. And then from 500 to 600 would be 100 points. And from 600 to 700 would be another 100 points. And then from 700 to 750 would be 50 points. And we can add these up to get our answer. So we have 200s, 50, 75. 200 plus 25 plus 50 is 275 points. And so let's check with the algorithm and see if this turns out to be true. And I will change to red to do this one. I cannot take 5 from 0, so I'm going to borrow one of those and give to this one. And then I can say 10 subtract 5 is 5. I cannot take 7 from 4, so I'll borrow. Let me change colors so you can follow what I'm doing. I will borrow one of those and give to this one. 14 take away 7 is 7. And 6 take away 4 is 2. And there is the answer that we already found. If you like the algorithm, that's fine. This is called algorithm. If you like the number line, that is fine, because you will get the same answer. And let's check our answer against theirs. And sure enough, Fran needs 275 more points. And that's what we got in both of those. I like the number line, actually. Okay, let's make one more line, and we'll do one more example from our textbook. And let's take a look at a hint down here. Always look at the hints in the textbook. It's good stuff. 5, 10, 25, 50, 100, 200, 250, and so on are called benchmark numbers. And we'll be practicing using those. You can use any numbers you want as benchmarks, but I like these because I understand them based on money. Nickels and dimes and quarters, dollars, those are easy for me because I'm used to thinking about money. Okay, let's look at page 27. And here is a test example. I'm going to work this in my notebook just as one more example, and I'm going to do it both ways. So let's go back here, paste it down, and I'm going to copy it into my notes. If you are planning to go to college, this is a very good skill to develop. Being able to copy things into your notes will be very helpful to you. Not quite like that. All right. A food truck sold 246 hot dogs. End of sentence. It sold 329 burgers. End of sentence. Here comes the question. How many more burgers did it sell than hot dogs? Question mark. So as soon as I see that question mark in my notes, I'm going to highlight that question. Okay. And then I'm going to look for my keywords. Let's get rid of that. Okay. I see a key phrase that is incredibly important, and that is right here. As soon as I see that in a question, it means subtract. If it's in a question. And what is it asking me to subtract? Burgers. Here's another keyword that means subtraction. Than. If it's in the question. How many more burgers than hot dogs? So let's look back up here for some more information. That is so critical. And I see the 246 hot dogs. I see the 329 burgers. And those are the things it's asking me to subtract. You put the bigger number on top. And we're subtracting the smaller number. And that will give us the algorithm setup. Okay. However, before I do the algorithm, I'm first going to model this one. I like to do both examples so you can choose. So this one would be 3 flats. You don't have to make them perfect. You're sketching. 2 rods and 9 cubes. Okay. And then we have 2 flats. 4 rods and 6 cubes. So all I've done is sketch the model. And then I'm going to make a line because this is where my subtraction begins to occur. And I'm going to always start here. Okay. So let's cancel out what we can. I can cancel those two. These. You are eliminating what you can. And what you cannot eliminate, you will bring down. So those 3 right there, oops, sorry, had the wrong tool. Those 3 are coming down here. All right. Then let's move here. Now, I cannot take 4 from 2. The 4 is bigger. The bottom is bigger. Better borrow. So let's move over here, and we're going to take one of those flats. So I'm going to rename this flat as 10 rods. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is gone away because I renamed it right here. It's not gone away. That's not the right word. I have renamed it. It's still here. I've just renamed it into its rods instead of its flat notation. And then I can begin to cancel here. So I'm going to take this one and this one, 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 and I'm left with these that were not canceled. So I have 1, 2, 3, 4, 5, 6, 7, 8 of those to bring down here. This is not my favorite way, but some of you may like it, so we'll do it this way so you can see. And then over here we have to cancel, so we get those 2 to eliminate each other and that one. So there are no flats left over here. So my answer would be 8 of those rods and 3 of those cubes. So I'm looking for an answer of 83. All right, let's try the number line method and see what we can do. So I'm going to say, here's my number line. I need to change the tip of my Apple Pencil. That's what's making that skipping. So I'll do that before we start the next page. All right, so put yourself some dots. And down here we have the small number, the 246. Up here we have the 329. And we want to start making benchmarks. So I know that 250 is a close benchmark right there. Let me keep my numbers all on the same row. And then from 250 to 300 would be a good benchmark. And then from 300 to 329, we'll figure that one up. And something here, oh no, I'm sorry. I had myself confused. 246 to 250, you can count that on your fingers if you want. 46, 47, 48, 49, 50. That's 4 spaces. And in this case, well, I won't confuse you with that. Let's just put 4 there for now. Then from 50 up to 300 is 50 spaces. And then from 300 on up to 329 is 29 spaces. And when I add up these, that's 54, 64, 74, plus another 9. I'm adding those to get the sum of 83. So you can get your answer that way. You can also just use the algorithm, where 9 take away 6 is 3. I cannot do 2 take away 4, so I will borrow here and make this become a 12, just like we did right here. This became 12 so that I could take away 4 to get 8. And then, of course, there's nothing here, So my answer is 83 burgers. So on this number line, this was 4 burgers. This is what I started to say a minute ago, and I didn't want to get us confused. But these represent burgers. There were 83 more burgers than hot dogs. And if you look back at their answer, they got the same thing that we did, and so they chose answer C. Let's look at the hint. Subtraction is the opposite of addition. If you have to find a missing part, you can subtract the known part from the total. And you don't have to worry about that too much, but I want you to know that subtraction, this is algebra right here. Subtraction is the opposite of addition. There's a fancy word that means opposite, and that is the word inverse. You will see that when you get to algebra, but it simply means that subtraction is the opposite of addition. For example, 3 plus 5 is 8, and 8 minus 5 is 3. Those are opposites or inverse. That will be very important when you get to the algebra chapter. All right, let's practice here. Read each question, select the correct answer. Which equation does the number line show? So let's study this. Let's get our starting and stopping points. That would be very important. The stopping point is 314. The starting point is 127. So I am looking for something with those numbers in it. And so I'm liking B automatically because B is the one that puts my starting point and my stopping point into play. And that is actually the answer I want because this unknown part is represented by these arrows. This part is this part. And I've got a pen that's way too big. But that's the answer we're looking for. 127 plus some unknown amount is 314. And all we have to do is pick the correct equation. We do not have to solve it. You're doing algebra right there. As soon as you introduce that unknown, that question mark, you're doing algebra. Number 2, what do you need to do to subtract 306 minus 293? So I think on this one, I'm going to use the algorithm because it will get confusing really fast if we don't keep it as simple as we can. So let's see what we can do right here. 6 take away 3, I can do that. That's 3. 0 take away 9, I can't do that. If the bottom number's bigger, you better borrow. So I'm going to take 1 from this one and give it to this one. And I'll go ahead and finish it to get a difference of 13. So what did we do? Did we group one of the hundreds into 9 tens and 10 ones? Did we group 110 into 10 ones? Did we regroup 100 into 10 tens? That's what we did. We took one of the hundreds and made it into 10 of the tens. Or did we regroup 100 into 10 ones? We did not do that. We regrouped 100 into 10 tens. Number 3. How do I want to do this one? 557436. I want to do that one with the model, if I can find a place to do it. Let's do it right up here. 557, that would be 5 flats, 5 rods, and 7 cubes. And then what was my other number? 436. So 4 flats, 3 rods, and 6 ones or cubes. So let's draw our line. This is a good one to model because we don't have to borrow, I don't think. And then let's start eliminating. So here are my ones to be eliminated. So those pair off, these. I'm left with 1 down here. Then the rods, we pair them up to eliminate them. And then we have 2 that could not be eliminated. And then here we have 4 sets that can be eliminated with 1 left over. So this represents 121. And that's the answer I'm looking for. 121 is A. That was a good one to model. All right, the next one is a word problem. So let's treat it as we do all word problems. A small town has 478 houses and 233 apartments. Here comes the question. How many more? Sorry, that's huge. How many more houses than apartments are in the town? So if you mark off your key phrase, right there it is. If that's in the question, you need to subtract. And it's asking you to subtract houses and apartments. Than is another keyword. Than tells you that this number goes on the bottom. So on the top would be the houses, 478. Okay, that is clearly not what I wanted to do. And 233. And I'm going to use the algorithm on this one. 8 take away 3 is 5. 7 take away 3 is 4. And 4 take away 2 is 2. So I like answer D. There are 245 more houses. Okay, number 5. Which equation does the drawing show? So here I started with how many flats? 1, 2, 3, 4, 5 flats. So that's 500. 1, 2, 3 rods, that's 30. And then 1, 2, 3, 4, 5, 6, 7, 8 of those singles. So 538 minus something. It has to be D. If you can get that far, you've got the answer. You have 538. But let's look at where they're getting the 103, because this is interesting as well. There's 1. So that's 100. And then they subtracted 3 of these. So there's your 103. So you have 538 minus 103. And you do not have to solve it. You just have to be able to read that model. And that's where you need to know your flats, rods, and cubes. Number 6. What do you need to do to subtract 502 minus 264? So I'm going to use the algorithm and see what I need to do. I cannot take 4 from 2, but there is nothing in the tens column to pull, so I'll have to go all the way to the hundreds. I'll take one of those, share with that one, and then I'll turn around and take one of those to share with that one. So what did we do? We grouped 100 into 9 tens and 10 ones. We had to regroup twice. So we took this one flat into 9 rods and 10 cubes. The others, we did the others, but we did 2 of them. Okay, so the only one of these that shows 2 regroupings is A. Number 7, they want us to subtract 466 minus 306, and this would have been a good one to do a number line on, but I'll go ahead and just do the algorithm. 6 take away 6 is 0. 6 take away 0 is 6. And 4 take away 3 is 1. So that's going to be B, 160. All right. 398 people are waiting at a train station. 217 people get on a train. How many people are left? The key word is left. If left is in a question, you want to subtract. And we're looking for people. How many people are left? So I want to look back in my question for people and people. And that will allow me to set up my problem. And I'm going to try to do a number line for you right here. I'll tell you what, let me erase. You can use scrap paper, but I'm trying to keep all of mine here on this page. So let me get rid of this and we'll have a little bit more space to work with. So on our number line, we're going to put the points where we start and stop. And let me get over here back to my black ink. So the lower number is 217. The higher number is 398. And we need to benchmark our way up to the answer. So 217, I'm going to go to 25. Because that I can do that one mentally. So from 17 to 225 is 8. And then from 225 to, let's just go to 300, I think is what they're wanting us to do. So that's 75 in that space. And then from 300 to 398 is going to be 98. And so when you add those together, 75, 98, and 8, you will get 16 plus 5 is 21. 9, 10, 11 plus 7 is 18. So I'm liking 181 people are left. So you could do the algorithm on this one. Let me do that for you because that probably would have been the easier thing to do. 398. The algorithm is fastest if you understand the algorithm. But if you're having to sit here and work with the algorithm, it may be better to use a number line or a model on that one. But any way you do it, you should get C 181.